Good morning, all. I welcome you for the lecture series in the course Material Science and Metallurgy. As we are seeing in the last class, let us recap the topics we have discussed. So this is what in the last session we have seen the different types of heat treatment process that is applied. And let us explore in this class what is annealing. So annealing is nothing but it is a heat treatment process in which material is exposed to an elevated temperature for an extended period of time and then slowly cooled. Okay. So when annealed part is allowed to cool in the furnace, it is called full anneal heat treatment. So it does not mean that you should keep the material that is heat treated inside the furnace where the temperature is constantly applied. It is a part of the furnace where there is no heating coils. So that is the meaning you should understand. And it is in an open environment so that there is a movement of air where the heat is transferred slowly. So we call it as full annealing. So we have different classifications of annealing. One is full annealing and what we have seen there. Next one is process annealing, and we have stress relief annealing, recrystallization annealing, and periodized annealing. These are all the different types of annealing we have. Here you can see a axle which is coming out from a furnace. So the purpose or the objective of full annealing is to soften the metal, relieve the stress, and refine the structure. So this is what it happens when you go with microstructure like this, and coarse grain annealing will change this machining steel into this coarse grained microstructure. So this is the equilibrium diagram which indicates full annealing and normalizing temperature for carbon steels. So temperature annealing is like 30 to 50 degrees centigrade above the upper critical temperature for hypoeutectile steel, and 30 to 50 degree above the lower critical temperature for eutectile steel. Cooling is done at the furnace at the rate of 10 to 30 per degree per centigrade per hour. For hypoeutectile steel, the resulting microstructure is coarse perlite and ferrite. So coming to full annealing. So we have hypereutectile steel, annealing temperature is the same, and hypereutectile steel resulting microstructure is coarse perlite and cementite. So it is like a fingerprint what we have, the fringes, it is like that. So this provides high ductility and toughness. So the stress relief annealing is nothing but recovery annealing. We call it as recovery annealing because due to different manufacturing process like cold working and forging, everything, there are a lot of residual stresses which will be trapped inside the grains. So uniform cooling is mandatory in this stress relief annealing, as well as it eliminates stress formed during welding, cold working, casting, quenching, and machining. So need for surface or stress relief annealing is the causes for stresses is due to plastic deformation during machining, non-uniform cooling, phase transformations between phases with different densities. And the effect of stress may cause warpage, crack, distortion. So recrystallization annealing is nothing but replacing by strain few new grains without phase transformation. And the temperature of recrystallization is nothing but 40% of melting temperature. So recrystallization temperature, it reduces the dislocation density and converts elongated grains to equiaxed grains. So this will be the structure of iron carbide and iron. And we have a structure after spheroidizing. We are getting a globules which improves machining. So here the lamellar perlite is converted into globular perlite, plates of cementite into spheroids of cementite. Yes. So with this, we will see in the next class about normalizing. This is all about annealing. Thank you all.